Hi everyone, in this video I want to show you one of my books. It is Calculus Volume 1, Introduction with Vectors and Analytic Geometry by Tom M. Apostol, California Institute of Technology, Blaisdell Publishing Company. Very nice book. This book feels amazing to hold. Like, it just feels like it's quality. It's really well made, which honestly it needs to be, because this book, and this is probably the worst thing about this book. This book is expensive. Like, it's not cheap. You can find it on the internet. I'll try to find it and leave a link in the description, but like, it's not cheap. And that's the worst thing about this book. I'm pretty sure there's copies out there for like over $200. I've seen them. So it's up there. And so Tom Apostol, he was a math teacher, right? He taught mathematics, and I believe he did number theory. And he worked at the California Institute of Technology, and he lived to be 92 years old. So he lived a long life. He was the son of Greek immigrants, and he had his name changed. His original name, I believe, was something like Apostolopoulos. And when his parents became citizens, they changed their name to Apostol, and then so Tom inherited that last name from his father. So actually, he's kind of just an interesting background on Apostol. And I have a picture of him here if you want to take a look at what he looks like. Here's the man behind the legend, behind this very expensive book. If you only knew how expensive his book was, you know, he knew, but he lived a long life, 92 years old, I believe. A long time. So let's take a look at this book. I'm going to open it up. We're just going to look at it and explore it. It's a very good book. It's definitely harder than your regular calculus book. I definitely recommend this book. I think it's a great book. Nothing negative to say other than the price of the book, right? It's expensive. Yeah, nice. I just have to smell it. I just got to give it a whiff. I can already smell it. This one has a particular like old comic book smell. Yeah. It smells like I used to be an old comic. I used to collect Amazing Spider-Man comic books. I was really into that, and so that's what it smells like. So let's look at the contents briefly, and then we'll just look at some of the mathematics. I think that'd be more fun. Let's just look at some of the actual examples and see if we can make sense of them. So it starts with integral calculus. Integral calculus. Turn the page here, and then it goes into more concepts here, and then differential calculus. The logarithm, differential equations, got some first order stuff, second order stuff, vector stuff, lines, planes, dot products, curves and surfaces, the cylinders, circles, parabolas, the mean value theorem and its generalization, some applications of it, infinite series. So this is Calc 2 stuff, infinite series. And that's it. And this is volume 1. So there is another volume, right? So it's not everything. Let's just open up to a random page and see what we find. So let's see. This is Bolzano's theorem and the intermediate value theorem. Okay. So a little bit more advanced. It's not computational, right? Nothing computational there. Inverses of the trigonometric functions. This is interesting. This is something that people have a hard time with in trig, is computing the values of the inverse trig functions, because they think, you know, you have to pay attention to the range, right? You have to pay attention to the range of the trig function. For example, here they have f of x equals sine x if x is between negative pi over 2 and pi over 2. So they're defining the sine function on that particular interval. They're restricting the domain of the sine function. And the reason you do that is because by restricting the domain, you're able to take the inverse, because then your function is invertible. Otherwise, it's not invertible. You know, it won't even pass the horizontal line test. You see here, here's the picture of the restricted sine function. And then over here, you see the inverse function. You see both graphs, sine x on the left and arc sine, or the inverse sine, on the right. So, and you learn that in trig, and that restriction of the domain and all that in a trig class. I think it's overwhelming to people. It's just something that they're not used to seeing. So yeah, and here's already he's talking about the integral of 1 over the square root of 1 minus x squared is arc sine x. Yeah. And then over here, he has the integral of arc sine x. And he looks like he's going through something there. Here's some of the exercises. Derive the differentiation formulas in exercises 1 through 5. Okay, yeah. That's pretty simple. It's not too hard. 4D, number 4, is a little bit interesting, because you have to pay attention to the domain and the range and stuff in order to justify that absolute value. It's a little bit more delicate there. That's number that's number 4, right, in the exercises. So that's pretty hardcore. I mean that example is significantly harder than like the first one, right? In my opinion. Yeah, nice problems. And he has answers. So if you're wondering, is this good for self-study? Sure. This is a collector's book. This is good for everything. This is what it's all about right here. This is one of those books. It's like, yeah, this is the Apostol book. It's one of my best books. Like, it's one of my, as a collector, this is pretty nice. This is pretty nice. Yeah, so you see he has most of the solutions, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's a couple missing. The smell of the book, it's intoxicating. I just have to smell it again. I'm sorry. It's just, wow. Just, oh, wow. Someone left a comment once about that. So if maybe you know about this, there's something with, they even left a link, and the link worked. Usually when you leave links in comments, YouTube like auto deletes a lot of stuff. So someone left a link once saying that these old books, something with the chemicals in the books, that they produce a smell, the chemicals that have sense of like vanilla, and I don't know if it was lavender and something else. There's chemicals in the paper that decompose, and it was like a chemistry thing. It was showing that these chemicals produce these scents, which are generally liked by people. For example, I'm pretty sure that like most people, like there's been studies, I think, where they say like most people think vanilla is a scent that's pleasing. That's why there's so many like vanilla sprays. Like, a lot of women, I think they have like products that smell like vanilla, and lavender is another popular one. And I think those are things that human beings perhaps are naturally drawn to. And it's like the smell of decaying paper. It's just wonderful. It's just amazing. Look at these curves. These are the integral curves of the differential equation. Yeah, lately I've graphing is interesting. It's something that a lot of people don't like. I was looking at a book the other day, and it had a lot of really interesting graphs in it. And I was thinking like, yeah, someone mentioned that there's entire books filled with graphs. Like there's books of graphs. I think that's interesting. Maybe I'll have a couple of those. I should mention one of those one day and show you. They're really cool. Solve the differential equations in exercise 1 through 12 by separating the variables. Okay. Yeah, all right. So like number 1, y prime equals x cubed y squared. So you would write that as dy dx and then separate the variables and integrate both sides. That's not so bad. Some of these are pretty good. This class, someone wrote in it. I don't think this copy is signed. I don't think it is. I have a bunch of books that are signed. I found a book the other day that was written by the author, made the book, and he gave a new copy to his colleague, and his colleague was also a famous mathematician. So it's like really cool. You have a book written by a famous mathematician, and he gives it to his friend and signs it like with sincere gratitude and like gives it to him. It's kind of cool that, it's like a piece of history. Some stuff with vectors. Straight lines. As before, we shall denote P, the vector OP, from the origin to an arbitrary point P in space. Let P not be a given point anywhere in space, and let V be a given non-zero vector. If the vector P minus P naught joining P naught to P is parallel to V, then there's a scalar T such that, yes, that's true, or what amounts to the same thing as, yep. Yeah, that's useful. That's very useful. That's a useful equation. That's cool. The scalar T is called a parameter, and this equation is called a vector parametric equation, or simply a vector equation. Yeah, so this is the set of points P satisfying this equation is called the straight line through P naught parallel to V. Yeah, cool. Scalar triple product. Wow. What are the diagrams? I wonder how they did those in the old books, like how they actually did that. That's kind of interesting. Here we have, looks like a determinant of a 3x3 matrix. Yeah, because you can use that to compute the cross product of two vectors, which they do here, right? Here's the cross product of two vectors using the determinant formula. So basically what you do here is you, like for example, for the first piece here, you cross out this row and this column, you get negative 8, 3, 4, 3, and there you see it and you have the I. And the pattern is plus minus plus. And then for the second one, you cross out the jth column, well rather the second column and the first row, you get 2, 0, 3, 3, it checks. And for the last one, you cross out the last column in the first row. So 2, negative 8, 0, 4, yep, it checks. No typos in the book so far. So I'm sure it has typos. I haven't found any, but I'm sure it has mistakes. Quality pages. Yeah. Yeah, it's nice. Really clean copy. So I think this is a good book for anyone who, if you're wondering, like, should you buy this book? Is it a good book? A lot of people wonder. My opinion is this book is good for anyone who wants a math book. Like, it's just awesome. It's a classic, right? It's one of those books you have forever. Hopefully you have all of your books forever. That's my goal, at least. Keep them forever, I guess. What's the prereq for this book? Well, a lot of effort, a lot of, the more math you know, the better. If you already know some calculus, that's better. I mean, it's going to take a lot of work. Also, having some knowledge of proofwriting would be highly beneficial before reading this book. I mean, there's a lot of things that aren't proofs. You could certainly skip those, focus on the computational aspects. I mean, you could do that, but it's certainly better, I think, to have more. The more math you know, the better. But I don't think that should be a reason for a person to not explore it. You know, I think a lot of times people are curious about the prereqs for something because they're wondering, you know, do I have enough to explore it? And a lot of times the answer is no. Right? A lot of times the honest answer is no. Even if you already have some skills, maybe you're just not ready for it, right? Maybe your math is just not at the level that's presented in the book, right? You're just not there. And that's okay. But I think you could still jump into it and you could still try and you can still do your best. I mean, that's how you get really strong, you know, by jumping in the deep end. I remember one time I was out in the ocean, and this was when I was first learning to surf on it, and I paddled out on my board, and there was these two guys, and they looked really rough looking guys, and they were out there, and I paddled out, and I was like, hey guys, and I wanted to surf with them, and they said to me, I said, hey, what's up? And I fell off my board, and I told them, oh, I'm just new, I'm just learning. And the guy looked at me and he goes, oh, you come out here, you're going to learn really quick. And I was like, yeah. And it was a perfect day. I mean, perfect waves, just one of those amazing days you never forget. But, you know, jump in the deep end. So you can do the same thing with mathematics, right? Jump in the deep end, and it's a lot safer than surfing. So no sharks, you're not going to drown. The board's not going to hit you on the head. But it's certainly a lot harder. It's a lot harder. Right? A lot harder, and it takes a lot more time. Circular helix. Cool, right? Yeah, it's just an intoxicating smell with this book. The general equation, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Cool. Yeah. A good look at this book. Rotations of axes on the plane. Here's some more exercises. Identify the locus represented by the given equation. When the locus is a conic, sketch the curve and indicate the locations of important features, such as foci, vertices, center, asymptotes, etc. Yeah, conics. Conic sections are really interesting. Really cool. I studied cryptography a long time ago, and there was actually, we were doing some stuff with conics in cryptography. So, I mean, conics are very, they go pretty far. And I hear, curvature. Oh, nice. That tells you how sharply a curve bends. So the greater the curvature, the sharper the bend. That's the idea behind, that's the intuition behind curvature. Looks like here they're computing some things. Yeah, there's a formula for curvature. That's one of the formulas for curvature. That's one of them. Zoom in so you can see it. There's a couple others. It says here, In practice, it is usually easier to apply this formula here. Yeah, that's true. You know, all other books say that too. The Stewart book says that as well. The Larson calculus book says that as well. A lot of books say that this is more easily done, and it's true. It's true. There are some times though when the other formula is also good. So I recently did a problem with the other formula, and I was thinking about that comment, and I was like, oh, yeah. Well, I didn't use it, but that's just one example. There are other examples where the formula that they recommend is the one that you're going to use. Curvature is something you study at least in the US. If you took a Calculus 3 class, that's when you would study curvature. Same thing with cylindrical coordinates. This would be a Calc 3 topic. Applications to planetary motion. Yeah, pretty cool, right? You can use math to describe what happens in space. That's just, the more, I've always been a pure math person. I was a pure math major, and I took a lot of abstract algebra and analysis and stuff, and topology. I like that stuff. But the more math I learn, the more I start to appreciate certain things. Your tastes change over time as you learn more math, as you grow mathematically. You discover new interests, and I appreciate certain applications, not all. Different people like different things. Some people hate statistics. Some people hate statistics. What's this? Use equation 710 to establish the following inequalities. Wow, cool. Taylor's formula with remainder. Oh yeah, look, they were underlining this. Very careful. They must have had a ruler there. Yeah. So this is the tangent line, isn't it? It says here, for example, the linear polynomial has the value f of a and the derivative f prime of a at the point a f of a. Geometrically, this means that the graph of g is tangent line. Yep, it's the tangent line. Yeah. Good. So he mentions that. That's the first order Taylor polynomial also for a function centered at x equals a. Same thing as the linear approximation or the tangent line approximation or just the equation of the tangent line. They all mean the same thing, pretty much. So yeah, calculus, beautiful stuff. And here's the formula. Let f be a function with derivatives of order n at the point x equals 0. Then there exists one and only one polynomial, p of degree less than or equal to n, which satisfies the n plus 1 conditions, namely, so it's unique. So it's a unique expansion. It exists and it's unique. Yeah. Cool. And then here's where the center is not 0, or just in general, it could be anything. Yeah. When you look at the series, when you let n go to infinity, you get the series. It's called the Taylor series. And then this one, when n goes to infinity, it's called the Maclaurin series. The Maclaurin series is just a Taylor series centered at 0. Let's see if we can find Taylor series here. Is it in this section? Does he make that leap? Let's see. I don't think he moves that quick. No. Not yet. O notations. Extreme values, proof of Rawls. Rawls theorem. Other tests for extrema at a stationary value. Someone really worked through this book, right? Look at all that writing. That wasn't me. Someone maybe perhaps in the 60s. You wonder who they were. And where they are now. I always wonder when I find books with names in them. I always Google the person, and it's really interesting. I've found a couple people just yesterday, and I think one today, just because I've been looking at some books, and it's interesting. Here's some limits. This is L'Hopital's rule. Yeah, there's all kinds of ways to spell it, by the way. I'm pretty sure you can spell it hospitals. I'm pretty sure that's a correct spelling. Someone explained it to me once. I knew someone who spoke French, and they were explaining it to me, but I forgot. So he doesn't mess around. Look at number 1. The answer there is a over b, so it's pretty easy. Yeah, you can do a lot of these in your head, but like that should be 3. Number 4 is 0. Number 3 looks really interesting, right? That's a cool problem. That looks fun. Some cool problems in this book. And you have answers too, so yeah. I just got a whiff of it again. It's just rising from the pages, and it's just like so I'm sorry, I gotta give it a whiff here. Just one more. Wow. Tom Apostol. Yeah, the legend. Great book, though. I think it's excellent. Whoops. It's an excellent book. We should take the dust jacket off and look at the book without the dust jacket. Let's try that. Just to see what it looks like, so you can get a good look there. I think they put like plastic on the dust jacket, so I appreciate whoever did that. That's good. Look at that. Calculus Apostol Volume 1. Beautiful. Yeah. Wow. The weight. Anyways, I probably should end this video. Thanks for being a subscriber. I just wanted to sit down here and show you a book that a lot of people, so a lot of people have been asking about this book for a long time, for years, and I always just forget. There's other books like that too that I really need to mention because people have been asking. So whenever you leave a comment, by the way, and you ask me about a book and I heart it, I read your comment, right? Because I only heart comments that I read. So basically that's what I do. Just that way you know. If I don't heart your comment and it's a good comment, it means I probably didn't read it. So and I don't have time to reply to all of them, so I don't always reply, but I just try to, like, I'm behind. I haven't read all my comments. It's too many. But I do appreciate all the book recommendations because that's how I learned to get books. So someone was recommending philosophy books to me earlier because I bought a philosophy book earlier because I have another book, which, let me see if I have it here. Let me just check. No, I don't have it. I put it away. It's another book I wanted to show you. It's really cool. It's a book that they used in the army in the 40s to train army people. And so yeah. So I bought a philosophy book for the army after reading that book. Is the story basically. I was inspired by the army book. So yeah. Anyways, until next time, I just wanted to show you this book. Good luck and take care.